radius 4 centimeters is being pushed up a ramp at a rate of 7 centimeters per second. The ramp is 630 centimeters long and 300 centimeters tall at the end. A point P is marked on the circle as shown. Picture is not to scale. They let us know. So this, okay, so it says how far, this is the first question. How far does the wheel travel in one rotation? So the wheel has a radius of 4 centimeters, and when they say one rotation, they mean how far up it will go in one rotation. Well, it'll go however long it is around the circle. So how long is it around the edge of that outer circle? It is the circumference of the circle. The circumference is equal to 2 pi times the radius. So 2 times pi times the 4, and that will give us 8 pi. So the distance that it travels in one rotation is 8 pi centimeters. And we can turn that into decimal. It makes more of a sense to a real number for you. You could. However, the most accurate answer is 8 pi. All right, moving on. It's question 2. Traveling at 7 centimeters per second, how long does it take the wheel to complete one revolution? In one revolution, we saw that it's going to travel. It travels 8 pi centimeters. It's supposed to be the word travels. Which means it travels a distance of 8 pi centimeters. So that means that we are given a distance, and they're asking us for a time. So how long would it take you to travel that distance if you were going at this speed, 7 centimeters per second? So I always remember the equation that relates distance and rate and time. It's dRt. It's almost like the word dirt, but instead of an I, there's an equal sign. So, because I honestly always get confused. Like, do I need to take the 8? I know what I kind of sort of need to do. I'm like, do I divide the 7 divided by 8 pi? Well, or is it the 8 pi divided by 7? So to help me, I write out the equation D equals RT. Then it's asking for how long, that's the time. So the thing they're asking for is time. So I need to solve this distance formula for T. I divide by R on both sides. So if I want to find the time, I have to take the distance traveled and then divide by the rate, how fast they are going. So that means they traveled 8 pi centimeters, and then divided by 7 centimeters per second, and that will give me the time in seconds that they travel a distance of 8 pi centimeters, which happens to be one revolution. So this answer is 8 pi over 7. And always you can check your answers too, because by checking, just by ignoring the number parts and looking at what we call, these are units. It's called unit analysis. Just looking at the units alone, will the units end up being seconds like they should have been? Because the centimeters, there's a centimeter in the numerator, there's a centimeter in the denominator, so those will cancel. Then there's a fractional second in the denominator. Well, what's going to happen to that? It's going to be flipped over and sent to the numerator. So our final answer here, the units will be correct, seconds, if we do this calculation of the distance divided by rate. All right. So even if you forgot this equation, if you just pay attention to the units, they can direct you in the right direction. All right, then they say, what is the initial height of the center of the wheel? We look at the picture here. This is the center of the wheel. And we're going to be writing an equation from when it starts here and it goes all the way up to the top of the center of the wheel here. We're going to be writing an equation for its height. So where is it starting? And what I would say is right here, I would call this like 0, 0. And it's starting off the ground. The center of that wheel is off of the ground. So it's 4 centimeters off the ground. So your initial height of the wheel is 4 centimeters. Next, they ask, traveling at a speed at 7 centimeters per second. Then they ask, in 1 second, how much does the height of the center of the wheel increase?
Camille, I have the video. It's a